everyone, welcome back to this month's STEAMkids Science Experiment Kit with the Washington County Public Library. So, this month for February, we have 3 separate science experiments that all have one sweet theme in common: candy. Candy is, well, wonderful, of course, but it's also a very popular thing right around now with Valentine's Day and sharing the love through gift giving of candies and chocolate. So I thought this was a very fitting theme. So we're going to try a handful of different science experiments today with a couple of different candies, including Hershey Kisses, Skittles, and MnMS. So just as a warning, these candies do contain things like milk. So keep that in mind in case you can't eat these candies. Some of them you don't have to eat to do the experiment, but just as a note in case anyone has allergies. So I want to know, what kind of candy is your favorite out of these 3? I personally really love M&Ms because I love all the bright colors and I love chocolate. Skittles are a close second. And then who doesn't love Hershey Kisses? So before we jump into our experiments, I want to talk about a little bit of the science behind chocolate, and then we'll start on our sweet experiments. So, did you know that chocolate grows on trees? Well, kinda. The fruit that gets turned into chocolate grows on trees, called cacao trees. And these grow in warm tropical places in North, Central, and South America, as well as in Africa and parts of Asia. And the trees form these long cucumber-like fruit, which you can see right here. And they have seeds in them, which you can see right here. Those seeds are removed from the fruit, and then they're dried in the sun. And then they get roasted to bring out the flavor, like coffee. And the hard outer shell of the seed, or the seed coat, if you remember from last month's activity, is then removed. And then the insides are ground down into a paste that is called chocolate liquor. Not to be confused with the adult beverage. They just have the same name, weirdly. But when that chocolate liquor dries, it turns into something that we know as baking chocolate. We can get that in the supermarket to make all kinds of yummy candies. And baking chocolate has equal parts of cocoa butter and of chocolate solids. Those are the 2 things found in these cocoa beans when they're roasted. And those are the 2 things you need to have chocolate. And in order to make different types of chocolate, you have different ratios of the cocoa butter and chocolate solids. A ratio is how we understand how much we have of different things. Since the chocolate liqueur or the baking chocolate have equal amounts of chocolate solids and cocoa butter, we call that a 1-to-1 ratio because they have the same amount. But there are different products made from cacao beans that have different ratios. Cocoa powder that we used in baking to make things like brownies or to make things like hot cocoa is the chocolate liquor with the cocoa butter that's removed from it. So all we have left is chocolate solids and maybe a little bit of the cocoa butter. All the chocolate that we eat in candies has sugar added to it as well as more cocoa butter. That's what gives chocolate its creamy, sweet flavor. So milk chocolate also has milk added to it, whereas dark chocolate does not. It just has the sugar and the extra cocoa butter. And white chocolate actually has no chocolate solids. It's just cocoa butter and then added sugar as well. So now that we've learned a little bit about the science of chocolate and about ratios, we are going to conduct our experiments. So in your kit, you have 3 Hershey Kisses. You also have 1 little pack of Skittles, and you've got 10 M&Ms, somewhere around 10. I tried to count them all. And you also have an experiment sheet that you can go through as we do these experiments and fill them out. The only things that you will need from home are a timer. A cell phone works really well, or you can just keep watch on a clock. And you're going to need a little bit of water. Everything else we have included in the kit. Oh yeah, also included in your kit, you're going to have a small bowl, a small little cup that you're going to use for the M&M experiment, and you have a white paper plate that you'll use for your Skittles experiment. So, now that we have all of those, let's get started. So, for experiment 1, we are going to be testing the dissolving rates of Hershey Kisses in our mouths. So, you are going to be eating your Hershey Kisses for this project. So, just word of warning if you can't eat chocolate. And we are going to be eating 3 Hershey Kisses. So, parents, if you don't want them to eat all 3 all at once, you can spread this out over time, just as a note. So, for this experiment, we're testing different rates or different methods of dissolving chocolate in our mouths. The first test we're going to put the Hershey Kiss in our mouth and not move. We're not going to move our tongues. We're not going to chew up the chocolate. We're just going to leave it there and let our saliva do the work. Our saliva, or our spit in our mouths, while it can be pretty gross, it's also really, really good at its job, which is breaking down food. So we want to see how good and how fast it is at dissolving a Hershey Kiss just on its own. All right, so before we start this process, we want to come up with a hypothesis. Hypothesis is a pretty fun word, and it's kind of hard for me to say, but hypothesis means a educated guess in a science experiment. So this is what we think is going to happen. So which one of these 3 methods do you think is going to be the fastest? Do you think it's going to dissolve fastest if we don't move our tongue and we don't chew it up? Or do you think it'll be the fastest if we chew it up and move our tongue like we would normally eat a Hershey Kiss? I wonder which one it's going to be. Write your hypothesis on your experiment sheet and let's see which one. Write your hypothesis on your experiment sheet and let's see if you were correct at the end. Not going to chew it. So we're going to see how long it takes, just our tongue moving it around in our mouth to dissolve. So take note of what time you put the Hershey Kiss in your mouth, and then at what point there's no more Hershey Kisses in your mouth. Okay? Meet me back here when you're done. Okay, so now you have your first one, you had a Hershey Kiss and you didn't move your tongue and you didn't chew it up. And the second Hershey Kiss, you just moved your tongue around to help potentially speed up the process. How long did it take you this time? Was it faster than the last one? I'm interested to know. So, our third experiment. We are going to put the Hershey Kiss in our mouth and chew it up and use our tongue. So just like you would normally eat a Hershey Kiss, put it in your mouth and see how long it takes for you to eat the Hershey Kiss and to have it fully dissolve. Take note of what time it starts and at what point there's no Hershey Kiss in your mouth. And come back here when you're done. All right, so now we have done all 3 of our Hershey Kiss experiments. So going back through, we're going to look at the times on our sheets and see which one was actually the fastest. And you can circle that result on your sheet. Which one was the fastest for you? For me, it was part 3, where we chewed it up and used our tongues to move it around. So, was your hypothesis correct? And why or why not? One reason why doing number 3 would be the fastest is that that's what our mouths and our bodies are made to do. That's what teeth are for, and that's why we have our tongues, to help us eat and move around food in our mouths so that our saliva can work even better at breaking food down. If we do things that change that, like where we only use our tongue and we don't use our teeth, or we don't use our mouth at all other than holding the Hershey Kiss, it's going to take a little bit longer. So, I hope that you enjoyed that first experiment, and I bet it was super tasty. So, let's go on to our second experiment with Skittles. So, for this experiment with Skittles, we are going to be placing them in water and seeing what happens. So, do you think that they are going to melt? Do you think Skittles float in water? Let's find out together. So we are going to take our white plate that is included in your kit, and we're going to place our Skittles along the outside edge of the inside of the plate. So we want them to be covered with water, but you can make any type of design or a pattern that you want with your Skittles in your packet. So then we are going to gently pour water on the plate until the Skittles are covered. And what will happen next? Before we do our experiment with the Skittles and the water and everything, we want to make a hypothesis like we did for the last experiment. So, what do you think is going to happen if we put Skittles in water and wait 5 minutes? You can write your guess down on your experiment sheet under hypothesis, and then we are going to write down and see what happened after 5 minutes and see if we are right. So, write down your hypothesis, and then we're going to take our plate, lay out our Skittles on the outside, and pour water over them and wait for 5 minutes. Meet me back here when your timer is up, and let's see what happened. So, our 5-minute timer is up. What happened to your Skittles? Was your hypothesis correct? And why or why not? So for my Skittles, we have them all kind of bleeding and blending together. The Skittles are now totally white. All the colors come off of the outside, and all the colors have sort of blended in towards the center, which I think is really cool. It made this really cool rainbow effect. Is that what you hypothesized would happen? You can write down below on your experiment sheet what happened and why you were right or why you were wrong, and maybe even what you would do next time to make it different. All right, so now it is time for our third and final experiment with candy today. Today, we are going to be putting M&Ms in water. So, this is pretty similar to our last experiment with the Skittles, but we are going to be placing our M&Ms in a little cup that's included in your kit, your little clear cup. You're going to place your M&Ms down in the bottom, and you're going to cover them with a few inches of water. You want to cover it with enough water so that they're submerged or underneath the water, but maybe not all the way to the top because you don't want to make a mess. So, and you are going to watch them and wait for 10 minutes. It may seem like a long time, but you never know how long you need. And we'll see if we need to use all 10 minutes for that. So, with the M&Ms in the water for 10 minutes, what do you think is going to happen? Are they going to float? Or will the colors come off of the M&Ms? And what do you think happens to the little M that's written on them? Do you think the same thing's going to happen like the Skittles? Or is something else going to happen? So, write your hypothesis below on your experiment sheet, and then we are going to place our M&Ms in our cup, cover them with water, and watch and wait for 10 minutes. And come back here when you're done, and we'll see what happened. All right, so 10 minutes have now passed. Was your hypothesis correct? Did you see anything super cool? Something really cool happened to mine. So I put my M&Ms in my cup and covered them with water and waited 10 minutes, and some of the M's written on the M&Ms floated to the top of the water. They came right off the M&M. That was super cool and not something I was expecting to happen. And I looked it up, and apparently it's because that M is written in a non-soluble special food paper, which is really cool. So it's non-soluble in water, which we've talked about a few times in STEAMkids. If something is soluble, it means it can be dissolved, or it will break down and spread out in water when it's mixed in with water. And we've found out that the coloring on both Skittles and on M&Ms is water soluble because the the color comes off of the candy and mixes into the water, which is pretty cool. But as we found out, the little M written on them is not. I thought that was really cool. So, was your hypothesis correct? Did you guess the right thing? And if you didn't, why do you think it was different? If you thought they were going to float but they didn't, why do they not float? I think it might be because they're pretty dense. They're really heavy, and M&Ms will sink to the bottom. So, I hope that you can have a good reflection on what your hypothesis was, and I hope that you had a really fun time doing these experiments. So, that is the end of our candy science experiment project this month with STEAMkids with the Washington County Public Library. I had a lot of fun putting this project together, and I hope that you had fun doing these experiments, and I hope that they were pretty tasty too. So, thank you all so much for all of your involvement and fun here with the Washington County Public Library. STEAMkids aren't going anywhere, but I am, I'm afraid. I'm moving on to a new job, but I'm really excited to see where STEAMkids goes and all of the cool experiments and fun things coming up in the near future. Our librarian Amy is going to be taking over from the Gray Library, and she's going to be awesome. She's going to do an amazing job, and you guys are going to learn so much from her. So, I hope that you guys have had a fun time with me, and I look forward to seeing what all you do in the future. Thank you so much for learning with me, and I hope that you come back next month for our next STEAMkids project. Bye!